Okay, said I'd do 61 through, what is it, 81? There are more questions than that coming your way in the second half. And what we're hoping to see is some progress with 4 more tests after this first one. The first one was a clear indication that some folks aren't looking at any of the material, the answer keys at night, and that's your prerogative, but you do so at your own peril. What a way to start a video. All right, so graphical approximation. Talk about that a little bit. We cover this up. So, how do we graph square root of 2x minus 4? Well, we've certainly seen it on every test. It's been on about 12 tests so far, I'm guessing. And we hopefully know what it looks like and the importance of the square root of 0 geometrically. And so I superimposed x minus 2 graph, which goes through y-intercept of -2 and an x-intercept of +2. And I put on the side here the square root of 0 is 0, square root of 1/4 is a half, half times a half. So that's actually, at this instant, going up faster than the linear function x minus 2, which has a 1-to-1 slope. Okay, this goes up by 1/4, this goes up by 1/2. That's twice the size of this, so it's going up faster. But then we know square roots, they increase slowly, very slowly. The bigger the x, the slower the rate of increase. All right, so what do we anticipate here for an answer? I threw a 2 in just to get started here, try to give you a frame of reference and realize that we have one intersection at 2. So one of our answers is 2. Sometimes we get extra answers on these problems. And I've explained it before. I'll do it one more time. X equals 3, x squared equals 9, x equals plus or minus 3. Only one of those answers satisfies the original question. All right, so sometimes squaring brings in an extra answer. And in this case, it doesn't appear to. So let's do the algebra. Let's find this other value. I'm going to guess it's around 4 or 5. I don't know. Let's find it. So square this side, x squared minus 4x plus 4. Squaring a square root gets us what's inside. Adding 4 makes that 8. Taking 2x away makes that minus 6x plus 8. And here's x squared. Okay, so we got our x minus 2, x minus 4 equals 0. And there's one answer, which we said we knew. 2 gets us 0 in both tables. You put a 2 in here, that x is 2, that gets you a 0. And you put a 2 in here, it also gets you a 0. So what do we learn from that? That the equations are the intersections of 2 graphs. 4 is going to be the same thing. 8 minus 4, that gets me 2, and 4 minus 2 gets me 2. I bet you 3 is not equal. 6 minus 4 is the square root of 2, and a 3 up here gets me 1. Yeah, that doesn't work. And I don't think any others are going to work other than x equals 2 comma 4. Okay, so we talked about that. Again, I'm talking fast, and the reason is I've been at it since 5:30 this morning, haven't stopped. So replay everything that I say. All right, replay it a few times and do something called thinking. Look at it, think about it. Okay, and you'll find that you can make some gains that maybe you didn't think you could make. Where are we at? All right, so how do I write this equation? Well, we're basically saying, let's start at 6 units over here. We're really close to 6. It's never going to equal 6. It's going to equal things like 6.0. There's always going to be something at the end. Okay, because this is a growth function above 6. So the question is, how much above 6 is 11? I would say 5. How much is 6? How much is 21 above 6? Well, I know one thing, it's not 5. Oh yeah, I gotta compute it. It's actually 15. And that's the hard part. That's the hard part. And then knowing that b to the 0 is 1 and b to the 1 is b allows us to quickly say x minus 20, 20 over 9. And every single one of those numbers is coming from that picture. And if, once again, you think about it, I think you'll get it. All right, so that's there. How to graph exponentials is certainly on the web page. Just type my name in and there's probably a rapid fire 5 where I do 5 of those. Certainly gonna put those on the homework assignments over the holiday. I'll have plenty of time to go through all those videos that give you plenty of practice with this. All right, and plenty of practice doing circles. So let's do a circle right now. Completing the square. X minus, you gotta cut that in half. When you square it, you get 81. I don't see 81 floating around anywhere up here. Get rid of it. Then we got cut that in half. I don't see -1 anywhere floating around here, so get rid of it with, I'm sorry, +1, right? Squaring that gets me +1. I don't see +1, get rid of it. And that equals 18. So that gets us our Pythagorean relationship. X minus 9 squared plus y minus 1 squared equals 81, 82. Yeah, a nice round number, 100, which is 10 squared. So there's our triangle, x minus 9, y minus 1, and 10. And we're looking at those areas. That's what these statements are about, the areas. And what's at the center of this rotation? Whatever makes that length 0, which in this case is 9. If this one gets bigger, that area gets bigger, this one's got to get smaller, and we get that rotation. So 1 radius is 10. That's the radius right here. Goes around, lots of triangles drawn. We'll study that extensively in trigonometry. All right, so I think I'm asking domain and range on this too. So let's draw it out. Here's 9, that's an x value. And I go 10 in this direction, and I go backwards 10 in that direction. That takes me to 19. This takes me to -1. Those are the x values. 1 is the y value. I'm going to go up 10, takes me to 11. I'm going to go down 10. That takes me to what? -9. Okay, now we put 9, 1 in here. When I move to the right, I'm still in altitude of 1. I guess all I asked was domain and range, but that is the y value. The x isn't changing. The x isn't changing. And over here, the y isn't changing. So those are the coordinates. All right, so let's go back to domain and range. So domain is all about the x's. So what am I seeing? I'm seeing x's that are less than or equal to 19, greater than or equal to -1. Then the range is the y's. Oh, I think it's greater than or equal to -9, but smaller than 11 or equal to 11. And that all these y's, that y value right there is somewhere between -9 and 11. Somewhere between these. So is this y. Okay, so we talked about that. I'll erase the board as I go. And I'm sure that over the holiday, I'll look on the web page and try to group everything that you need to know for your exams coming up. All right, so we're looking for exponential activity on top of m. I'm looking for the exponential activity on top of m. I think this could have been written as 1 over m to the 7th. Because I can bring m to the -2 into the denominator. Of course, 1 over m to the 7th is the same thing as m to the -7. And that's being cubed. And I'm looking for the exponential activity on top of m. I think I found it. It's -21. I'm looking for the exponential activity on top of m. No, you either get it or you don't. M is being squared and it's got a 9th root. It's just another way of writing. M to the 2/9 means the 9th root of m squared. And we keep talking about it. And hopefully that will make some sense to you at some point. All right, we're just doing some reducing of fractions. Okay, so 14/28 is a half. X to the 3 is being divided by x to the -5. How do I want to say this? Well, x to the -5, I guess I got to change it to 1 over x to the 5 right now. Okay, and when you divide by a fraction, you multiply by its reciprocal. So that becomes x to the 8th. So what's the shortcut? Where there's a negative, you can rewrite it as a positive. Same thing over here, where there's a negative, which is really 1 over m to the 4th, is getting divided by m to the 22 over 1. That's the same thing as 1 over m to the 4th times 1 over m to the 22. So I hope we can see 26 in the denominator. And hopefully that's pretty mechanical for many of you now. One more chance to see how that worked. If you didn't pick it up on that, play it again, Sam. All righty. Bingo, bango, bongo. Leave it alone. Just do that. Get in the habit of doing that and then do it again. What's bingo? 2x plus 7 times 4. 8x plus 28. Okay, we already took care of the minus sign. Bango, 3 times 2x plus 1 is 6x plus 3. Bongo, 12. Oh, okay, I put it in there, that's all right. So 8x minus 6x, I can see that now. 2x. 28 minus 3. 25. Divided by 12. Oh, well. All right, where am I at now? I'm at, oh yeah, this was the math department. Yes, it was a worksheet. Okay, I'm back into the land of the living. All right, so what do we got? Cosine and sine. Most people say sine and then cosine. Just this year, I'm changing to cosine then sine, because cosine has to do with the x values and sine has to do with the y values in a unit circle, which you'll study later. So I'm going cosine sine. So the cosine of angle A, adjacent over hypotenuse, that's already given. Don't have to do anything for that. The sine of A, we're going to have to work for a little bit. So we got what? 81 minus 16, 71 minus 6, 65. So square root of 65. So the sine of angle A is root 65 over 9. And it seems like everybody's doing that pretty well in class these days. So I'm not going to talk much about that. And rise over run for tangent, which in this case is root 65 over 4. So that one's done. All right, user-friendly numbers. What are user-friendly numbers for log base 2? I like 1. I like 2. I like 3. No, I don't like 3. I like 4. I like 8. There we go. I'm on it now. You know, I think those are all pretty user-friendly numbers. 0, 1, 2, and 3. Okay, well, what makes 2? Well, let's start over here. What makes x over 5? O equal 1. I think 5. It's a very easy friendly number here. What makes x over 5 2? I think 10 would be a nice number here. So on and so forth, right? So makes that 4. 5 times 4, 20 is user-friendly. 5 times 8, 40 user-friendly. Now we see a pattern. We're doubling things. 80, 160, lots of friendly numbers. Of course, I didn't have the camera on there. So, refresh. Told you, I've been at this a long time today. Okay, I'm sure you heard it. Now it's such a mess, I should do it again. Very quickly. All right, so here's the original problem. Looking for nice numbers for x to plug in there. Well, you got to be able to do the computation log base 2 of 1 or log base 2 of 2, log base 2 of 4. I got a feeling that one's easy for you. Right? Log base 2 of 4 is 2, log base 2 of 8 is 3. Got a nice pattern here, yes. 0, 1, 2, 3. So it looks like x over 5 would be nice if it was 1. So I guess 5 is friendly. Oh, what if I want it to be 2? 5 times 2 is 10. 10 is friendly. What if I want it to be 4? 20 is friendly. What if I want it to be 8? 40. Oh my God, 5, 10, 20, 40, 80, 160, 240, 320. There's so many friendly numbers there that give us integer friendly answers. Then I could probably multiply this by 7 and still be okay. Okay. Let's get that out of the way. What's the next one? Domain. All right, so I got a calculation here. Domain is what I can use. So I guess I'll look at the numbers that are critical here, which are 1 and 3. Can I use those numbers? Let's put a 1 in. 1 minus 1 is 0. The square root of 0 is 0. 1 minus 3, negative 2. If I put that in a calculator, it comes out as 0. I can use it. Put 3 in there. It gets me the square root of 2 over 0. I put that in the calculator and it goes, whoops. Can't use 3. Oh, yes, we got to look at numbers less than 1. Let's plug 0 in. I get the square root of negative 1. Whoops. That's not on the Cartesian coordinate system. That's an imaginary. So I can't use these. No. Let's pick something bigger than 1. Let's pick 2. Well, that 2 minus 1 is 1. Square root of 1 is 1. And 2 minus 3 is negative 1. I think I get an answer on the calculator. Looks like that's okay. Pick a number bigger than 3. 7. 7 gets me the square root of 6 over 4. I don't have a problem with that either. Looks like the domain. Let's go interval notation here. 1 we said worked. 3 didn't. But bigger than 3 did. Well, there's the interval notation, which we've been using in class. All right, quadratic formula. We haven't done much with it. Everybody uses it so much, they think it's a rite of passage, I guess. I'm trying to get you to memorize by doing different letters here. So we'll develop it. It's probably good for you to see where it comes from. So minus b over 2a is the most important value for x in a quadratic. And so you want to make it a 0 in the parentheses, then you have to say plus b over 2a. And so if you complete the square, b squared over 4a squared is what you get when you square that. B squared over 4a squared. But if you multiply that by a, we can see one of the a's cancels. So that's the number we get when we put a 0 in here. But if we put a 0 in here, we want that last number, in this case c, because I'm solving this for ax squared plus bx plus c equals 0. So I get rid of what I don't want, I bring in what I do. That's a fraction, that's divided by 1. I got to multiply it by 4a and 4a. If I do that, I get minus b squared plus 4ac over 4a. And that's still getting multiplied by x plus b over 2a squared, right? That's still here. So I'm going to move this to the other side. Subtraction becomes addition. Addition becomes subtraction. And I end up with this, 4a squared. All right, I think I skipped this step. Yes, I should have been showing this. Subtraction becomes addition, right? And then we do what? If this moves over to that side, we divide by a. We divide this by a, we get 4a squared. That's gone. Then we take a square root plus minus. That's gone. And then positive b over 2a becomes minus b over 2a. And we can put everything over 2a. That's the quadratic formula. So let's get rid of that. You can replay it all you want. So the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. If I'm setting it to 0, what I'm really doing is finding out when a quadratic hits a height of y equals 0, which splits the graph into 2 parts, y values that are positive and y values that are negative. Might be useful to know those values. All right, so I'm giving you different letters. That's all I'm doing. And so what do we have? Minus e plus minus the square root of e squared minus 4de all over 2d. It just works the brain a little harder. And maybe allow you to memorize that a little better. I just want you to have it memorized. So this solves any quadratic. It's cumbersome. There's quicker ways to do things, but there is useful information here inside the square root that we can talk about, but we got other things to do first. All right, so what do we got? Linear function here. So x minus 2031 plus pi over 2. That should look familiar. That's only a change of 2. 19 pi over 2 to 19 pi over 2 is 18 pi over 2. I gotta add that many to that to get here, which is 9 pi. And there's your linear function. And I'm doing this because it's going to help you when you get to trigonometry. So if you know how to write the equation of line, we might as well start doing one that's going to have some real meaning down the road. All right, so what do we got? Piecewise function. Well, that's V-shaped down. So my first slope is positive. I'm going up. My second slope is negative. I'm going down. So I'm going to make 2 branches here. The up branch is just the line to x plus 5 plus 3. And the one going down is minus 2x plus 5 plus 3. But there's a critical number here, negative 5. Negative 5 is critical. Because if I put a number bigger than negative 5, like negative 4, this is a positive. And if I even put a number smaller than negative 5, negative 6, gets me negative 1, it's still positive. So even though, you know, if we didn't have the absolute value symbol, x plus 5 crosses the x-axis at negative 5 and changes signs, the absolute value prevents it from changing signs. So the critical number here is 5. Negative 5, excuse me. So when am I going up? On this side of negative 5. For x is less than negative 5, and for x is bigger than or equal to negative 5, got to include negative 5 as part of the graph, so one of them's got to have to equal. It's going down. All right, so how's that helpful? Well, it's helpful if we want to find out when it hits negative 9. 2 x plus 5 plus 3 equals negative 9. Well, that's a piece of cake. Negative 12. Positive 6. Minus 5, 1. And how far is negative 5 to 1? 6 units. So it's probably 6 units in the other direction. Probably taking us to negative 11, but let's find out. So right now, one of our answers is 1. Now we're going to go, the other branch is the one that's going up, and that's the left side. So yeah, so it's going to be smaller than 1. All right, so what do we got? We still got negative 12, but now we get a sign change here, negative 6. And when we subtract 5, negative 11. Yeah, that's true. So that gives us 2 critical numbers. 1, negative 11. And we want to find out when we're bigger than negative 9. When are we bigger than negative 9? Is that what I wanted, bigger or smaller? Oh, I don't remember. I do not remember. It might have been smaller. Let's do smaller. Okay, so we have this V shape. We got a couple of values, and negative 9 is that altitude. And then the further I go to the right, the smaller I get. Over here, what did I say? 1. An x value of 1 gets us negative 9, right? And if I want to be smaller than negative 9, I think this continues to push rightward. Okay, so didn't draw that very well. It should have gone through there. Okay, so looks like that's going to be true. That's going to be false. That's going to be true. You can check it with numbers, but let's check it with any number bigger than 1. You say 2, I say 1,000,000. That's minus 2 million. Is that less than negative 9? By God, it is. Let's pick a number in between. 0, you say. Well, that makes that minus 10 plus 3. Minus 10 plus 3 is minus 7. Is minus 7 less than negative 9? On a number line, let's see. Here's negative 9. Here's negative 7. You know what? I don't think it is. You can check yourself, put a minus million in there. What happens when you put a minus million in here? Becomes positive million, brings us right back to the other side. All right, so interval notation. Negative 11, oops, negative infinity. Negative infinity out here, positive infinity out here. So negative infinity to negative 11, union 1 to infinity. Okay, hope you think about this. Greater than 0. Now, if you get to calculus, you're going to have to learn how to graph these, so I think I'll do it anyway. So this is to the first power, this is to the, they're all to the first power. That means they're all gonna change. If I copied it right. 3/2, 81/73, and 0. So 0, 81/73 is not as big as 3/2. So let's put a million in here. So put a million, that's a negative. Put a million, that's a positive. Put a million, that's a positive. So I'm going to get a negative outcome with linear changes at the roots. And I want to be bigger than 0. That appears to be negative infinity to 0. 81/73 to 3/2. Now, you want to probably make a sign change, 0. 81/73, 3/2. You try these numbers in here. All right, and see what you get. And that's how you determine your answer. All right, there's shortcuts to these conjugates. I'm just going to put the answer down, then we'll get it. So let's see if you can figure out the shortcut. 15 plus 10i over 13. Okay, let's see how we get that. So what's the conjugate of 3 minus 2i? 3 plus 2i. If you multiply the denominator and you don't want to change the size of the fraction, you got to multiply the numerator by 3 plus 2i. And what is 3 plus 2i divided by 3 plus 2i? The number 1. So it doesn't change the size of this. So what do we get? We get 15 plus 10i. What do we get in the denominator? 9. The middle terms cancel. We've seen that. We get minus 4i squared. Right? Minus 2i times positive 2i is minus 4i squared. What does I squared do? It changes the sign of the number in front of it, and that's where you get 13. All right, let's look at this one from a graphical standpoint first. So we got a cup shape up at 4, 9. And we got an A term of 3. So some of you can already write your answers. Right, so you got x is equal to 4 plus or minus. You got to go down 9 to hit 0. So there's no real roots here. So we got the square root of 9 over 3, imaginary, right? So how do we get that? Not doing the shortcut. Minus 9, boom, divide by 3. Boom, take the plus minus square root. The negative comes out, becomes I. Negative 4 becomes positive 4. That's how you mechanically do that problem. 5i to the 67th. You have not had much practice. You want to go to the web channel and definitely do rapid fire 5 imaginaries, whole bunch of these. By the time maybe I can do 2 or 3 here. So 60, 33 gets me up to 66. I need a multiplication of 1 more. That's 5 times negative 1, 33 times I. If we do that 33 times, negative 1 times negative 1 times. Every time you do a minus times a minus, you get a sign change. Minus times a minus is a positive. Now it's a negative. 3 gets me a negative. 4 gets me a positive. I suppose I should put them in parentheses, right? 4 of them get me a positive. 5 of them get me a negative. 6 of them a positive. 7 of them a negative. I got an odd number. It's going to get me negative 1. 5 times negative 1 times I, negative 5i. All right, I'll give you a couple more for practice here. You are seeing it tomorrow. Let's do 5i to the 75th, 53rd. I don't know what I'm talking about. All right, so what is that? 5i squared. How many times? Well, let's see, 25 gets me to 50, so it looks like 26 gets me to 52. I do need another one again. This time it's even. So I'm going to get 1. times I, 5i. Let's do 5i to the 40. Okay, what's that gonna be? Oh, that's gonna be 5i squared. Looks like I gotta do it 20 times. Negative, 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 20 times, that's gonna be 1. So I get 5. Let's do 5i to the, let's do 6i to the 99. Well, that's 6i squared. How many times? Well, 50, so 49. That gets me to 98. That gets me to 99. That's odd. So it's going to be minus 6i. Let's look at 3i to the 9th. Well, that's 3i squared. 4 times I. That's even. So that's going to be 1 times 3, 3i. All right, so hopefully with a month to go and practicing that every day. Of course, practicing it every day means you got to look at your answer keys from your tests. Or you got to make sure you do what you don't know how to do in class at the board. That's how you're going to move up the ladder. All right, so f of x equals x cubed. I like giving you a problem that, we haven't graphed much. I think we've done once or twice, but you can always make a table of values. Okay, negative 3 cubed minus 27. And if you look at these table values, let's do, that one gets me started. So let's say negative 3 gets me negative 27. Negative 2, negative 1 gets me negative 1, 0 cubed, 0, 1 cubed, 1, 2 cubed, 8, 3 cubed, 27. And then we get something that looks like that. Okay, I kind of missed it here. And we've had a lecture on that. I don't know if you remember it, but it was about surface area and some things. And there's plenty written about that on the webpage as to what's going on and why geometrically, algebraically, numerically, putting cubics in graphing form. Oops, that was an odd function. I was going to actually describe what an odd function was. So odd function is we have a function, and if it's odd, it follows the following definition. So let's put a 2 in. And let's have f be x cubed. Well, the 2 gets me an 8. An odd function means that f of minus 2, the opposite of that, also gets me 8. If that's true, for all instances, we call it an odd function. So what is negative 2 cubed? Negative 2 cubed is negative 8, right? 3 negatives. And if we hit that with a negative sign, it indeed becomes positive 8. So just thought I'd mention that. Not going to hold you responsible for odd and even functions at this stage, but you are going to have to understand that at some point in your math career. So it doesn't hear you hurting it. Doesn't hurt you hearing it. Good. Okay, as you can tell, I'm burnt out. So what am I doing next? Next, putting some stuff on the board for a little talk with the department tomorrow. Okay, bye-bye.